Right, on to part 7 now. So having plotted the graph, we obviously want to work out the gradient. So changing y over changing x. And this is where the little bit of legwork we did earlier on comes into it, where I demonstrate what I'm actually doing. So we can explain this a little bit more clearly. We squared the equation that we were given to give us t squared equals 4 pi squared l over g, and we compare that to the equation of a straight line. Again, this technique is something that's covered in other sheets, and you can go into it in a bit more detail. It's something you do really need to get to grips with. So if this seems a bit alien to you, then call up on some of those sheets and have a little go at practicing this with some other equations and experiments. So the way we do it is we compare the y equals mx plus c. This is effectively written in the lab diary before the graph gets plotted technically. But at the same time, you also know that this is where you're going, so it can go after the graph. It doesn't really matter. It justifies what we're going to use the graph for, basically. If, as we've matched up y as t squared, we've matched up x as l, what's left is 4 pi squared over g, which is the gradient. I think I may have misspoke earlier on when I said it was 2 pi. Of course, we squared everything, so it's 4 pi squared over g. So the gradient is equal to 4 pi squared over g, so if I calculate the gradient, then g equals 4 pi squared over m being the gradient. So calculating the gradient, I've shown the calculation up there, substituting that into this equation gives me a value for g, which I follow the units through, and it gives me 9.76, which happily is around about what I'm hoping for, given that we're hoping for 9.81 ultimately. So again, it's just that demonstration. Now, there's not lots of different versions of this of this calculation. I only do it once, but that calculation needs to be in there and it needs to be explained. So I don't want to pick this up and look at some random numbers and not be sure what it is you're actually calculating.